Okay, if you are given a question like this under calculus, this particular one is under derivative of logarithmic function. You see, log of x base a. Now, this a is a constant, x is a variable, so it's logarithmic function. Okay, function is here. And if we want to have the y dx, it's very simple. How do we find it? We cannot differentiate log x base a immediately because it's a non-linear function. What will you do? We first of all express it as index form to help us. And how do we do that? Remember, if we have that y is equal to log x base a, we can as well say a raised to the power y equal to x. So I've automatically changed it to a raised to the power y equal to x. This is index form. Now, how can we find the derivative of this? It's not possible. So take the in of both sides. So we take in a raised to the power y is equal to in x. Reason why we are taking in to bring down this y because it's also a nonlinear function. So y coming down, y in a is equal to in x. This is a linear function whereby we can now differentiate. We can differentiate in x, we've already done that. We can differentiate y, we've done that. Okay, then in a is now a constant, but in x is a variable. Take note of it. In a is a constant. Okay, constant. Y in x is variable for those who wish to know. In x is a variable, in a is a constant, and because of that, you keep this constant to differentiate y. If you differentiate y, you have dy dx. Then if you, this y is having 1 times 1 is 1, okay? Anything that raised to the power, look at it here, write 1 here. Then 1 minus 1 is 0, y raised to the power 0 is 1, so you have 1 here, okay? Then because, why am I writing the y dx again? Because I differentiated y with respect to s. Then in a is constant, is still there. In a is there, constant, I didn't touch it. Now, is equal to, if we differentiate in x, we've done that before, okay, is 1 all over x. So you don't need to stress yourself on that. Coming down here again, you notice that the y, the x, will be equal to 1 all over x. In x, if this should come down, okay, cross and multiply, this in s is down, or you divide both sides by in s, you get 1 all over x in x. This would have been our final answer. Or sometimes, if you're writing exam, you may not see this in the option. Okay, so you have it as dy dx equal to, let's separate it, 1 all over x dot 1 all over in a is the same thing, 1 times 1, 1, x times in a, x in a. Now, I say the y, the x is equal to, now watch this, 1 over x, and in a is the same thing as, in a is the same thing as log a base e. And again, 1 over in a is the same thing as saying log e base a. So if that is the case, anywhere you see 1 over in a, you replace it with what? Log e base a. I'm so sure you not get the thing that happened here. Let me show you. Explanation of 1 over in a. Okay? How come we have log e base a? In a, because we know that in a is log a base e equal to what? I'll say log e base a. Actually, it's coming from the law of logarithm. Remember the reciprocal law. Reciprocal what? Reciprocal law. 1 over log a e is equal to log e a. Reciprocal law. This one go up. This one come down. Reciprocal. That's 1 over e factor it's reciprocal. So log e a log a e. Such that if you multiply these two, you get 1. Because this will cancel out, this will cancel out. Like that. So here's the final solution to this question. Okay, that is if you are solving it a theory-based question. What if you are solving it for objective-based question? What will you do? For objective-based question, let's say what to do. You don't need to objective-based question. Remember, this is x, this is log base a, and y is equal to in x, the y, the s is equal to 1 over x. As long as this is log, whether this is log base 3, log base 5, log base 20, log base anything, as long as when you differentiate in s, you got 1 over x. When you see log x, your answer must be 1 over x. Okay? That one is settled. Now, you also say times log a. Because of this in that we have already used here, is appearing here, but you didn't say log a. This log base a will be here, and that e will be there. So 1 over x times log e base a. You stop. So anytime they ask you find log x base a, you do this. Okay, let's take this example. Y is equal to log x squared plus 5 base 2. Okay, find the y, the x. What will I do? I'll simply say the y, the x is equal to 1 over x squared plus 5. That is it. 1 over x. 1 over x squared plus 5, because here is x squared plus 5. Here is x, and that's why I see x here. Now, x squared plus 5, x squared plus 5. First, that's what you do. Then, because this is no longer x, but x squared plus 5, it has replaced x. You differentiate x squared. What will you get? 2x. You multiply the numerator by 2x. Differentiate 5 is 0, is gone. But that is not the end, because in this particular question, the base is not e. If the base is e, you stop here, you stop here. But now the base is 2. Remember what I told you, when you differentiate this log x base a, the answer must be 1 over x times log e base a. So I'll multiply it by log e base. What is our a here? Our a here is 2 base 2. So that 2x times 1 is equal to 2x all over x squared plus 5 log e base 2. So that is how you solve this question. You don't need to stress yourself. Then I would like you to solve this for me. Y is equal to log x squared minus 3 base 5. The y, the x is equal to what? Leave your answer in the comment section. If this is your first time of seeing my video, like, share, and subscribe to my YouTube channel for more videos. Bye.